Welcome to the Data Hall YouTube channel. In this video, we are going to continue our series on event study. So in our first video, we discussed the basic idea of event study and saw how we can apply event study in Excel. Then we discussed commands related to Stata, and we know that we have two commands in Stata that can be used. There are multiple, but these are the good ones. We had eStudy command, which we discussed in our previous video, which we can use in Stata to conduct event study. But again, we saw there were certain limitations with that command. And so to overcome those limitations, we have another command which is called eventstudy2. And this is what we are going to discuss in this video. So before we move forward, let me show you the files that we have. Now in eventstudy2, we need to have a separate data file for each of different types of data. So we have security returns, which contains the returns of the stock. We have factors file. Again, the name can be different, but we would have these three types of data files, right? The factors file that would contains the market return, the SME, HML, depending on what factors do we have. Then we would have event date data that would contain the events that we want our analysis to perform on, right? So this would contain the data related to events. So let me show you these stock returns. Now, as opposed to the eStudy command, in eStudy command, we need to have data in the wide shape. So we need to have each stock in its separate column. But in eventstudy2 command, we do not need that. We can have data in the long format. So we have all the stocks stacked on each other. We have Ford, General Electric, Apple, GM, IBM, all returns stocked on each other. So we just have RI symbol and the date in this file. Then we have the factors file that contains different factors. So we have date, market return, SMB, and HML, right? And lastly, we have event data, and this contains the dates on which that specific event had happened. So let's just say Apple announced dividend on this date, General Electric announced dividend on this date, and so on and so forth. So for the sake of comparability, I'm keeping the same dates that I used in our previous video of eStudy. That was the last command that we had, right? So let's dive into this command. Okay, so we would start with the installation of this command. So again, we would use ssc install event study 2. So I already have that command installed, right? Let's move towards the command. So we would have to import the data that we need to open into our system. Should be the event data, the data that contains the event dates. This was the data that I showed you a while ago. Now we need to perform the command. And let's first execute this command, and I would come back to the nuts and bolts of this command. Remember, it gave us an error, and it's saying that please install the user written program parallel. And now for your system, it might be a different package that it would need you to install, but it would give you multiple errors of these kinds. So you just need to keep on installing all the packages that it says that you need to install. So for me, it is saying that I need to install the parallel package. I already had it installed, but I uninstalled it just for the sake of demonstration. For you, it would keep asking for different kinds of packages that you need to install. Just keep on installing them, right? It can be 5 to 6 packages that it might ask you to install. So for me, I'm going to install this parallel package. So the parallel package had been installed, and I do not need to reinstall the event study command. I just need to execute it now. So now it would start executing. So it is going to take some time to execute. In the meanwhile, we would understand this command. So we start with the eventstudy2 command name, then we write the symbol, right, that contains the symbol data. Okay, then we have date variable name, which contains the date data. Using security returns, this is the file name that contains the data related to securities. This was the file, right? Let me just delete all these files. So we would have to run that again. Okay, so this was security return file that contained the security returns. So the return, the variable that contains the return data is what we need to specify in the returns option. So after comma, we have options. So first option would be returns, and within returns, we need to tell it what is the variable name that contains the return data in the security return file. Remember, this is the file name, security returns, and within this file, there is an RI variable that contains returns. So returns is the RI variable. Then we need to specify model, and for now just ignore what model means. For now we would just stick to FM, and I would discuss these different types of models later in the video. Then we need to specify the market file, and remember, this is the file that contains the factors, and I just have to specify the name without the DT extension. I just need to specify the name of the file. So in our case, it is the factors file name. You can have different file name, and whatever the file name you gave to your factors data, you need to specify that over here. The same goes to security returns, right? Within these factors file, there is a variable that contains the market return. So we have S&P 500 index, and we have calculated the return of S&P 500 index. That becomes the market return. So we need to specify the market return option and tell it what is the variable name that contains the market return. So in our case, it is MKT. Okay, then we need to tell it what is our event window. So the lower bound of the event window and the upper bound of the event window. So we, for the sake of consistency with our previous video, we are going to take 0.3. So starting from the date of the event plus 3 days from the date of the event. So that whole becomes our event window. Then we have estimation window. So we have lower bound of estimation window and upper bound of estimation window. So our estimation window starts 10 days before the event and continues 120 days before the event. Okay, so let me again execute the command, pause the video for a while. Okay, so command had been executed, and these are all the files that had been generated. Remember, we already had 4 files in this folder, and these are the extra files that had been generated. I previously had them deleted just for sake of understanding, but now we have them back. Okay, so what this eventstudy2 command does, it store each different types of data in its own data file. So instead of giving us the results in the output window, it would just store them in the data file, and that's quite good, because if we need to perform certain further analysis, let's just say we take that CER of different firms or events, and we need to perform certain other analysis on those CERs, then we can already have them in the data file. So we have multiple data files, and let's discuss these data files. So first we have this cross file, and this cross file contains the name of the symbol, or whatever the file name or whatever we had to represent the cross section, then the event dates, then the beta, because we had market factor, so we are using market model, we are regressing stock return on market, and for that we have betas. Then we have CER for each event. So with Estudy, it would give us 2 things. One would be each specific event's abnormal return, and then it would be the CER of for each event. So here in this file, it is giving us the CER of each event, and so you can see that there are 10 CERs, but they are all same values. And the reason is that it allows us to have 10 different event windows. So even if we just have one event window, it would just replicate those results in all these columns, right? So you can ignore all these things if you just have one event window. In our case, if we just have one event window. So these are the CERs of each event. This is the one file. Another file is CAR. Okay, this file. This is the CAR file, and it contains the cumulative average abnormal return (CAAR) of the event. Um, so this is the event window. Remember, again, we have 10 because we are allowed to have 10 different event windows. The number of firms that we had in this event window, the CAR, and we have different tests. So this is the t-test. Then we have Wilcoxon test and all the other bunch of tests. So it takes time to analyze these, to perform this command, because it is executing all these tests. Then we have AAR file. This contains the average abnormal return for each day of the event window and all the tests related to them. Then we have AR file. This is the abnormal return file. It contains the date, the symbol, and the RI. All these things coming from the security return file. Then the MKT, that coming from the factors file. Then the event betas of regressing this on market return, and then the abnormal return, the actual return minus the expected return calculated based on this market model. So we have this for all different firms and for all these are the abnormal returns. Then we have graph, right? So it would give us the graph of the CAAR, right? I'm not sure if we can specify the time period as we did with Estudy. Then we have diagnostics, and this diagnostic test, this diagnostic basically it isn't tests, but it contains the one of the file related to diagnostic is one of the file related to diagnostic contain different data. That is the symbol, date, the category that had missing, or etc. But we didn't had any of those issues, so we don't have any data in this. And the last file would be the diagnostic log file. It would contain all the log related that had appeared on the screen of the Stata that while we were executing this command. Okay, so from this you would have just the completeness of this command. It can do anything that you would require in your event study. So most probably, I guess 9 out of 10 times you can do your event study with this command. Okay, so we need data in long form as opposed to wide form as we had with estudy command. One thing is that estudy command by default use log returns, but this command, this eventstudy2 command by default use the simple return, which is the current return current price minus previous price divided by previous price. So if you need to use log return, which we normally do in our researches for different reasons, we would have to specify log, and this means log return. And again, if once we run the command, it would generate all these different files, and if we rerun this command, it would give us this error because the output files had already been generated. So what we need is we need to use the replace option, so that if we execute the command, it would replace all the files that had already been generated. So Now this with this setting, I have the result of this specific command would be comparable to the previous estudy command. And what I would do is, let me show you the results of estudy command and this command, so that you can know that they both are same results. So I quickly went back and executed the estudy, and let me open this file that contains the CER of each event, and let me bring in uh, the data from estudy command. So for Apple, we had this event, right? This is the same event date, and our CER was 1.30, which is rounded off, so we are getting 1.29. So if we round this off, we are to get the same values. Or what I can do is I can set decimal to 4, and this would exactly be comparable, right? So for GE, we had 1.36, right? So for IBM, we had 3.3096, right? For Ford, we had 10.15. So these are exactly same results as we were getting from the eStudy command. So whether you perform the eStudy or eventstudy2, so I would recommend using eventstudy2 because it is more of a robust or complete command. Okay. Uh, so let's explain the nuts and bolts of this command further in detail. We can use multiple event windows. The rest of the command remains the same. What I have changed is that instead of EVWLB, which is the event window lower bound and event window upper bound, I've eliminated them, and I'm using CR1LB, which stands for CR lower bound for the first event window, CR upper bound for the first event window. Then we have the second event window, and we can have multiples as well. So if I execute this command with the replace option, right, and with the log option, what it should do is it should give us multiple CERs for different event windows. Okay, so let me show you the results. We again have the rest of the things remain same. We get 3 CERs, and the other CERs are the exact same of CR3, and for the reasons that we already discussed. One thing that you would think is that although we specified two different event windows, why are we getting 3 different CRs? And the reason is that somehow it would still use the default setting for this event EVWLB, right? So this is the first one, and we have for these two we have the second and third CER. Okay, this is for the default window. So the default window is -20, -20 plus 20. So one of them is for that -20 plus 20 window, and this is what it is. The rest of these two are for the ones that we have specified, the CR1 and CR2. And if we open this CR file, we would be able to look into it. And these two are the event windows that we have specified, the -1 and 2 event window, and the 0 and 3 event window. And the rest is the default event window that are coming from this thing. Whether you specify or not, that is going to happen. So okay, so I hope that is clear related to different event windows. Okay, then we have estimation windows. Obviously, we can change estimation windows. There is a default setting of estimation window, but we also have different model types. So we have a total of 6 different model types. Although in eStudy command we had lesser number of options with this model type. So we have we have raw return, and the only thing that would change is we would have to specify in the model, instead of FM, we would have to specify raw. And that setting is related to the expected return, how the expected return needs to be calculated. So when we specify the model is raw, we do not need to specify the market file or the market return or the factors, because we do not have any factors. We are just using the raw returns for expected returns. Then we have constant mean, which is COMEAN. So we specify model as constant mean, which is equivalent to having HMM in the Estudy command. What it would do is it would take the average of the stock return as expected return, average over the estimation window. So again, when we specify a model as constant mean, we do not have to specify the market file and the market return. Then we have MA, market adjusted model, which is equal to MAM from Estudy command. And what it means is that it would take the market return as expected return, as the measure of expected return. And again, with MA, we would have to specify the market file and the market return, because we need to give it the market return data. Again, we have another model, which is FM, factors model, and this is equal to having SIM or MFM in the Study command. And if our model is market model or CAPM or firm and French three-factor model, or whatever model that we have, where we have multiple factors or even a single factor, we would have to calculate betas, and based on we would have to run regression, and based on that regression we would have to calculate fitted values. For that, we would use the FM model. And if we have just market return, so that means whether we are using CAPM or the market model, we just have to specify market return. But if we are using FF factor model, three-factor model, or some other model that have multiple factors, then we can specify up to 16 different factors. So using factor 1, the name of the factor in the market file or the factors file, factor 2, factor 3, and so on and so forth. Lastly, there is BHAR, buy and hold abnormal return, buy hold raw return, but this is out of the scope of this video, but we do have that option. Okay, so multiple events for the same firm. Remember, we had that limitation in Estudy command, and that is a major limitation. So for example, if our topic is to study the impact of dividend announcement on stock prices, so companies do not announce dividend once in their lifetime, so there would be multiple dividend announcement dates for each firm. So in that case, Estudy is quite limited, but that can be performed with eventstudy2 command. So let me have two different events for Apple firm. So we have, this is the one event, this is the second event for the Apple firm. And now if I execute this command, this is the same command as the first one, but we have just changed the data. Okay, let me show you that from the files. So we have two different events for Apple. So we get two different CERs for the same firm but different events, and that again would be adjusted in CAAR. Okay, so with that you can understand that it is quite a robust command. So there are multiple other options that I'm not going to discuss in detail, but just go over them. So in case you need to use them, you can use them, but just in case, if you want me to make another video, a part 2 of eventstudy2 video, do let me know in the comment box below, and I would be happy to make another video. So we have minimum observation of event window and estimation window. And what it means is that, let's say you are saying that estimation window should be of, let's say, 120 days, but for some events or for some observations, for some cases we do not have a whole data in the estimation period. We just have 10 observations. So would you want it to still calculate the abnormal return or not? So obviously I won't want it to calculate abnormal return if it just have 10 observations that meet the criteria. So I would like to set minimum estimation window, let's just say for 50. So it at least need to have 50 observation to calculate abnormal return. Similar goes to event window. You can set minimum number of observations for event window. You can also specify a risk-free rate variable. And the reason for having these factors in differently from market return factor is that, let's say you want to perform CAPM, you'd want market return to be adjusted for the risk-free rate. So that would be market premium. So this the risk-free rate will be deducted from the market return, but not from these factors. Then we have different market IDs, and what it means is that you are performing an event study on different markets. Some of these stocks are coming from US market, hence their index would be S&P 500. The others are coming from some European market, so their factors and their indexes would be different. So for that you can use ID, market ID. So you'd have to specify this market ID representing those markets in the stock return file and as well as in the factors file. So that way it would match the market and those factors data with those stocks that are specifically related to a specific market. We can also adjust for thinly trading days. So we need to specify a price variable, the trading volume variable, and then we need to specify this thin option where we would say that if stock dollar volume in terms of dollars or whatever currency you are using is less than this specific value, then eliminate those specific days. We can have multiple diagnostic tasks, and let me show you that from the help menu. So these are different diagnostic tasks. Then we have fill option, just in case you want to fill the missing returns values using some way. You can check that in the help menu, or you can delete the weekends, right? So I hope that was useful, and do subscribe to this channel and do hit the bell icon.